I started to collect examples of financial contracts in the Marlowe Contracts sub-project that resides within Marlowe Cardano. In Marlowe Contracts, there is, for example, a module called Options. An option is the right to buy or sell an underlying asset at or up to a specified time. We said a call option is the right to buy the underlying, put option the right to sell the underlying. A European option has to be exercised at expiry. An American option can be exercised up to expiry. In order to create an option contract, we need the following parameters. We need the exercise type, European or American, option type, call or put. We need two parties, a buyer and a seller. We need a price feed, which is a maybe type. That means that if we specify nothing as price feed, the buyer of the option has to do an explicit choice if he wants to exercise it or not. There's an underlying, which is represented as a token and a value. Same for strike, which is also a token and a value. Then we have the expiration date, which is a timeout. Settlement date is also a timeout. And the return type is the option contract. For the implementation, we distinguish between American and European option. As we know, the difference is that for the European option, we have to wait until expiry in order to exercise it. Whereas for the American option, we can exercise it anytime up to expiry. So let's have a look at the function exercise. Exercise creates a when contract. The list of cases is a single element list where the single element is created by the function exercise prime. In case there's no price feed, the choice to exercise the option has to be explicitly provided by the buyer. In case the option is exercised, the contract continues with deposit and pay. For the call option, the strike has to be paid to get the asset, whereas for the put option, the asset has to be delivered to get the strike. As we have seen in the slides, option contracts can serve as building blocks for more complex contracts that we call option strategies. A straddle is a combination of a European call and a European put option with the same strike and same maturity. The call option and the put option are composed concurrently to get a Marlowe contract representing the straddle. Another example in the slides was the call spread. Here we combine a long European call option with strike 1 and a short European call option with strike 2, both with the same maturity. Again, we concurrently combine the two contracts using the both combinator. In the slides, we also mentioned a covered call option. The covered call is a regular option combined with the underlying itself. In this example, the composition is sequential. That means we first deposit the underlying and then create the option contract. I think these examples show that we can express financial contracts in Marlowe in a nice compositional and expressive way. Most of the more complex financial contracts make use of concurrent composition of contracts. For this to be possible, we have added the combinator both. Both generates Malo structures that suffer from combinatorial explosion of the cases and therefore typically are really big in size. In order to tackle this problem, we use Merkleization. Merkleization is implemented in Malo core, where the contract examples are implemented using Malo extended. Malo extended is on the one hand side a simplified Malo, on the other hand extends Malo with, for example, parameterization. There is an idea to add a Merkleization step when translating Malo extended to Malo core. That means that Merkleization would be done implicitly and the contract writer does not have to know about it.